Hello friends, today I am going to discuss about the force of friction and I'm just introducing the what is called the force of friction. Suppose you have a body here and if you put it over a plane and if this plane is not smooth, then if we apply some force here, a new force will arise here exactly opposite to the direction of the force, and it is acting between the two surfaces. So uh, if you plot a graph here, so this is the force and this is the frictional force Fc. Now you will see that when we increase the force from 0, the force of friction is also increased, and then it will attain some maximum level. And this is the case of static friction. Up to this is the static friction, and this is the limiting friction. At this point, the force of friction is maximum. After that, it will decrease and it goes like this region is called the kinetic region, and this region is called a static one. Okay, so the limiting case, in the limiting frictional case, you can say the force of friction is Fs, static case, and this is mu s, and it is r, and this is mu s, r is mg here. So mu s is simply Fs by mg, and mu k is the kinetic friction, and mu k is always less than mu s. So these are the two things which is very important. Now, say this is a body and this is the weight of the body, and this is the reaction. It is actually put over a surface. Now frictional force is Fc, applied force is F here, and if the resultant of the F R and Fc is S, and if this angle is theta and this angle is called actually the angle of friction, then R equal to mg, and Fc, you know, Fc is mu mg. Again, if you resolute S, then S cos theta is equal to mg, and S sin theta is equal to F, and F equal to mu R. R is mg here. Now if you divide these two equations, you will get S sin theta by S cos theta is equal to mu mg by mg. So mg will cancel out. So then mu is equal to tan of theta. So this is the relation between the coefficient of friction and the angle of friction. Now we can take another case here. Suppose say this is an inclined plane, and a body is placed on it, and this is the weight of the body mg, and this is the reaction r, say, and this angle is theta, and this is the component of the mass weight, that is the mg sin theta, which actually provide the required force to slide down in the inclined plane. Now if you resolute r, and here Fc acting backward, and what is Fc? Fc is always mu r. What is r here? R is mg cos theta. Okay, so suppose say this is the equation number 1, and Fc is also mg sin theta. So Fc is mu mg cos theta, and this is mg sin theta. So mg will cancel out, and mu will become tan of theta. So this angle in this case is called the angle of repose. Angle of repose. So just by using an inclined plane, one can also find out the means if you able to measure the angle theta, then just by putting theta you can calculate the mu, that is the coefficient of friction between the body and the surface of the inclined plane. Now we will take another case here. Suppose now we will discuss very important situation here. Here we take inclined plane here. Suppose say this is an inclined plane, and this is the body, and the weight of the body acting downward, and the theta is the angle of the inclined plane. And if you take the component of mg, then mg sin theta acting downward, and a force P is acting upward with an angle of alpha. This is a reaction of the body R, and obviously this angle will be also equal to theta, and this is mg cos theta. Now if you take the component of P, that is the horizontal component, P of cos of alpha, and this will be equal to mg sin theta plus of Fc. Fc is mu r, that is the frictional force acting this in this direction. So this is equal to Fc, and in the second line we can write down like this: mg sin of theta, and Fc is mu r, simply mu. So mu r is equal to P of cos of alpha minus of mg of sin of theta. So this is equation 1, say. And the vertical component of P is P of sin of alpha is equal to mg cos of theta minus of r. So from here we can find out r is equal to mg cos theta minus of P sin r. So this is equation number 2. So we can use the value of r here in equation 1, and we can write down like this: mu of mg cos of theta minus of P sin alpha is equal to P of cos alpha minus of mg sin theta. So our aim is to find out P. So P will be, here you can take mg common, so mu cos of theta plus of sin theta, and here it is P cos of alpha plus of mu sin of alpha. So mu, as you proved earlier, mu is tan of lambda, and cos of theta sin of theta is equal to P cos of alpha plus of mu. Mu is again tan lambda sin alpha. Okay, so in a very simple, using very simple algebra, we can actually find out the more appropriate equation for P, and P will be simply like this: P is mg. Now you can write tan alpha is sin alpha by cos alpha. So in that way, P is mg sin lambda plus of alpha divided by cos lambda minus of theta. Alpha minus of lambda. Cos alpha minus of lambda. So this is again this theta. So lambda plus of theta. Here it is theta. And this is theta minus of lambda. So P to be minimum, cos of theta minus of lambda should be 1. That means theta minus of lambda equal to 0. So theta equal to lambda. So P minimum, there is a minimum force which is required to move the body up the plane is simply mg lambda plus of theta. In a similar fashion, we can also find out the minimum force in case of a body moving downward. So this will be equal to mg sine of theta minus of lambda. So these are two important results, and you must remember those expressions. Now I am going to take some example because in case of a fictional problem, we need to do some real example. Like say um, we have a body here, and this body say of mass of 10 kg, and it is placed over another body. Okay, and this the mass of the body is 40 kg, and it is placed over a smooth surface. This surface is not smooth. Suppose say the static friction is here is 0.6 and kinetic friction is 0.4. Now imagine a situation that a force of 100 Newton is applied on upper body. Then the question will arise that the what is the acceleration of this lower body. So first of all, we can take this problem like this. Means first of all, we want to calculate the static friction. Suppose say f of s. What is f of s? To know the f of s is mu of s r. What is r? In this case, r is only for the 10 kg body. That is the 10 into g. G is 9.8 here. So mu s is 0.6 and this is 10 and this is 9.8. You can also take it 10 for the sake of simplicity. So this will be 60 Newton. So as you see, the applied force, that is the F, if F is the applied force, 100 Newton is here, is greater than Fs. So that means the body will move, the upper body will move. Now, once it's moved, then kinetic friction comes into play. Now, what will be the kinetic friction? The kinetic friction is simply Fk is mu k into r. R is again 10 into 10 say, and mu k is 0.4. So into 100, that means 40 Newton. Okay. So if you want to find out the acceleration, then simply you can find out like this. Means this 40 Newton of force is acting on the body and the mass is 40. So this is simply 1 meter per second. So this is how you can solve these type of problems very easily.